Welcome back. This is part 2 of section 8.5 where we were talking about sum and difference formulas, and we're going to finish up by talking about the sum and difference formulas for tangent. So we separated this because it looks different from sine and cosine, and it's also visibly more complicated. So we're kind of doing these problems separately for that reason. Here are the two formulas you can see on the slide for the sum and the difference, whether you have a plus sign in the middle or a minus sign. But the formulas are so similar, it's just those signs that are different. So I've combined them into this one formula. Whatever makes you feel more comfortable, you should write down. And we are going to start with this first example. So the first problem asks us to find the exact value of tangent of 5 pi over 12. So that's another radian angle, one that we don't recognize because we're not used to these pi over 12 angles. So it's likely that we can get 5 pi over 12 maybe by adding or subtracting, but I'm going to try adding two angles that we do know. So let me just start by kind of guessing again like we did in the previous section. Maybe I'll do pi over 4, which is 45 degrees, plus pi over 6. Those two angles kind of helped us in the previous section because in the previous part we wanted pi over 12, so we still have another pi over 12 here. We just have 5 pi over 12 this time, so that's why I'm adding instead of subtracting. So hopefully this works out. Let's try it. We need a common denominator to add these things. These will have a common denominator of 12. That's why I chose them. So that'll be 3 pi over 12 plus 2 pi over 12, which is the 5 pi over 12 that we need. So what I can do is, or what we can do is, we can write tangent of 5 pi over 12 actually to just be tangent of pi over 4 plus pi over 6. We like those two angles because they're familiar angles for us. So let's go ahead and use our angle sum formula for tangent. So we're adding. So this is going to be, alpha is going to be the first thing. So we're going to have pi over 4 as alpha. Beta will be the second angle, which is pi over 6. So I'm going to plug very carefully into this formula. We have tangent alpha, which is tangent of pi over 4, plus tangent beta, which is pi over 6, all over 1 minus tangent alpha times tangent beta. So a lot of stuff to plug in here. What's nice is that they repeat though, so like tangent pi over 4 shows up in 2 places, so it's not like I have to find 4 different trig values. 2 of them show up in 2 different places. The hard part here is really going to be the simplification. So let's get started working on that. So what we have is tangent pi over 4. I'm going to replace these now. Tangent pi over 4 is 1, so it helps to know your basic trig values, plus tangent pi over 6, that's tangent 30 degrees, that's going to be square root 3 over 3. Moving down to the bottom, we have a 1 minus, so 1 minus, and now tangent pi over 4 is 1. I'm putting that in parentheses because I have to multiply it by tangent pi over 6, which is square root 3 over 3. Okay, so that simplified nicely. It's still not that cute, but we're going to do our best. So on the top, I'm going to leave that alone for now. 1 plus square root 3 over 3. On the bottom, we want to simplify this a little bit, so use order operations. 1 times square root 3 over 3 is just square root 3 over 3. So I have a 1 minus square root 3 over 3 on the bottom. Alright, this is not a pretty answer. So what we're going to be requested to do here is get common denominators on the top and on the bottom. And that way we can combine them into single fractions and then KFC. So that's just a look into the future. That's where I'm going. So I'm going to, at the same time, just multiply the 1 on the top by a 3 over 3 because I want it to have a common denominator with the fraction that's on the top. Same thing on the bottom. I'm going to multiply this 1 by a 3 over 3, so it has a common denominator of 3 with the fraction on the bottom. So this will become a 3 over 3 plus square root 3 over 3 all over 3 over 3 minus square root 3 over 3. So that's what we have. I'm going to move down here to continue my writing. These can be combined into single fractions on the top and on the bottom. So we should have 3 plus square root 3 over 3 on the top, and then on the bottom we have 3 minus square root 3 over 3. So now I'm ready to KFC. That's keep, flip, change. So I'm going to keep the top fraction the same, so that's a 3 plus square root 3 over 3. I'm going to flip the bottom fraction upside down. That's going to be a 3 over 3 minus square root 3, and change this to a multiplication problem. So hopefully when we do that, things cancel or simplify. We have these 3's that are going to cancel out, but nothing else does. So even though they look very similar, nothing else is going to cancel because they have different signs in the middle. One of them has a plus sign, one of them has a minus sign. So we get 3 plus square root 3 over 3 minus square root 3. Now for me, I think it's okay if you stop here, but I am going to keep going and show you how you can rationalize this. So the homework might not accept this, or if it accepts it, maybe if it's a multiple choice question, the answer won't look like this. They'll have rationalized it. So let me show you how to rationalize it. This has a square root on the bottom, which is what we don't like. We haven't really seen much like this though, because there are 2 terms on the bottom. So what I'm going to have to do to rationalize this is multiply by the conjugate of the denominator. So that's what I'm going to do. Multiply by the conjugate of the denominator. You might not recall what that means, but I will tell you. So the conjugate of the denominator is the denominator, but just change the sign in the middle. So I'm going to end up multiplying by 3 plus square root 3 on the bottom, and also whatever I do to the bottom, I also have to do to the top. This is going to help us rationalize. Get rid of that square root on the bottom. So hopefully I have enough room left to do this. If not, I guess I have some room off to the left I can write. But I'm going to move this up, and I'll show you what I would do here. So what you want to do is you want to foil the top and foil the bottom. So you have 3 times 3, 3 times square root 3 times 3, and square root 3 times square root 3. That'll be foiling the top. Foil the bottom, so I'm going to write that down over here. Now moving over as far as possible to give myself enough room. So that's going to be 9 plus 3 square root 3 plus 3 square root 3 plus, when you multiply square root 3 times square root 3, you'll end up getting just a 3, because technically you get a square root 9, but square root of 9 is 3. So that's what I get when I foil the top. Do the same thing with the bottom. So first outside, inside, last, we'll get 9 plus 3 square root 3 minus 3 square root 3, and then we have a negative square root 3 times a positive square root 3. That's going to be a negative or minus 3. So that's what we get when we FOIL the top and the bottom here. And now we want to combine like terms. So we should see some nice things happening. Just looking at the top, you have a 9 plus 3 you can combine. You also have the 2 things in the middle. So these 2 terms in the middle are like terms. You can combine them as well. That's going to end up being a 12 when I combine 9 and 3, and then plus 3 square root 3 plus 3 square root 3 is 6 square root 3. So that's what I have on the top. On the bottom, similarly, I can combine this 9 minus 3. That'll give me a 6. And then the 2 terms in the middle you can combine, but they end up canceling, which is really nice. And that should always happen. That's why this gets a special name, conjugate. When you multiply by the conjugate, you have the 2 terms that cancel out in the middle. So we just have a 9 minus 3, which is a 6 on the bottom. So you can see how that helped, because now it looks nicer and there's also not a radical in the bottom. We can simplify this more. So what we can do, every number that's not in a square root, if it's divisible by a common number, you want to do that. So all of these are divisible by 6. So I'm going to go ahead and divide them all by 6. That gives me a 2 plus 1 square root 3 over 1. And of course, those are invisible ones. I don't really need them. So that's a 2 plus square root 3. a much nicer answer than what we originally maybe would have stopped at. That's why this is beneficial, and a lot of times the homework will request that you do it. So, I know that was a lot. I'm glad I showed you. If you need to go back, rewind it, watch it again. Look up conjugate if you're not sure what that is. See some other problems on how to do it, but you will need to rationalize your answers like we've been doing all along this whole time. Okay, so we're going to do one more tangent problem, and that is going to be an identity problem. So I didn't leave myself too much room here. Hopefully I have enough space to do this. But we're going to use our tangent sum and difference formulas to help us establish identities. That means we want to simplify the thing on the left until it becomes the thing on the right. So I'm going to show us our formulas again on the slideshow. And this looks like it's the difference formula. We have a minus sign in the middle. So I'm going to be using the second formula. This is our alpha, this is our beta. So I'm going to go ahead and just plug into this. So tangent alpha minus beta is tangent alpha. In this case, alpha is pi, so that's going to be tangent pi, minus tangent beta. Beta in our case is theta, so that's that on the top, over 1 plus tangent alpha, which is pi, tangent beta, beta is theta in this case. So I just did our formula, but I plugged in pi for alpha, theta for beta. So that's what we get for tan pi minus theta. So some of these things we can evaluate. In particular, these two things we want to figure out. You'll notice theta is just an arbitrary angle, so that's just going to stay what it is. You'll notice our end result has a theta in it, so that's just going to stay what it is. But pi is an angle, right? 180 degrees is pi. So tangent of pi, you can use your unit circle to figure out what that is. Tangent of pi is 0. So I'm going to replace every tangent pi I see with 0. And that helps simplify this very nicely, because 0 makes things disappear, right? This is going to end up being just a negative tangent theta on the top, because you have 0 minus tangent theta. On the bottom, 1 plus 0 times anything is 0, so that's just a 1. And that ends up being exactly what we wanted at the end, which was a negative tangent theta, right? That's what we were supposed to end up with, and that's what we got. So that's the way that you can use the sum and difference formulas for tangent to prove identities or establish identities. All right, we have one problem left, and it is a little bit lengthy, so if you feel like taking a break, you can pause and do that. I am not. I'm going to go ahead and start it. And it is a build your own triangle problem, right? We can't escape them. They show up all the time. So we're going to be building triangles, and actually we're going to be building triangles, 2 different triangles, because we're going to have multiple angles. But the idea is the same, so I'm going to go through the setup a little bit more quickly, because we've seen these problems already in the past. So here's the situation. We're given 2 pieces of information with 2 different angles. So we have sine of alpha. We don't know what alpha is. It's some angle. Sine of alpha is 3 over 5. And this piece of information off to the right is telling us alpha is between 0 and pi over 2. Why is that important? Because alpha is in quadrant 1. That's what it's saying. Similarly, we have cosine beta. So beta is some other angle unrelated to alpha. And we know that cosine of beta is negative 5 over 13. And beta happens to be between pi and 3 pi over 2, which is in quadrant 3. So, and then we're asked to find sine alpha plus sine beta, or I'm sorry, sine alpha plus beta, cosine alpha plus beta, tangent alpha plus beta. What we need in order to find these things is we have to build our triangles first. So that's what I'm going to do. I'm going to start with my alpha triangle first. So I'm just going to build a triangle based on this information. So here's my alpha triangle. I'm going to build a triangle called this angle alpha. And they're telling us sine of alpha is 3 over 5. Sine is opposite over hypotenuse. So the opposite side is 3, the hypotenuse is 5. We've done these problems enough to know that you will need to find that missing side, and you can do that using the Pythagorean theorem. I'm not going to show that. I know that that's going to be a 4, but that is something that you would have to do on your own. And you want to remember this is in quadrant 1. That's important because it's going to determine the signs of our answers. S-I-G-N, the signs, positive or negative. And everything's positive in quadrant 1, so we kind of like that. Okay, so let's do a totally separate triangle for beta. So I'm going to create a totally separate beta triangle. So there's my triangle. There's the angle beta. And now cosine, which is adjacent over hypotenuse, is negative 5 over 13. I never mark them as negatives. If you want to, you can, but I let the quadrant tell me. That's the whole point of them giving us this information. Beta happens to be in quadrant 3. We will need to find that missing side there. I'm going to do that. It's going to be 169 minus 25, 12. So Pythagorean theorem, do that. And then remember that this is in quadrant 3. Why that's important, we're going to be using ASTC. So quadrant 3, we are here. Okay, so didn't take too long, but that's because we're used to doing this. I'm going to do first part A, of course, naturally start there. So A is asking us for sine alpha plus beta. So you want to look back at your formulas for sine alpha plus beta. That's going to be sine alpha cosine beta plus cosine alpha sine beta. That was a formula that we wrote down at the beginning of this section. So what we need to do is just fill in this information. What are sine alpha cosine beta cosine alpha sine beta? So I'm writing parentheses because we need to fill in those 4 pieces of information. And now we have these triangles, we can just look at them and fill this in. So sine alpha, we actually already knew that. They told us sine of alpha was 3 over 5. So I'm going to type that in there, 3 over 5. Great. Next up is cosine beta. They told us cosine of beta to start with. That was negative 5 over 13. Great. All right, cosine alpha is up next. So I'm going to use the triangle that we drew. Cosine is adjacent over hypotenuse. That's going to be 4 over 5. And it's going to be positive because we're in quadrant 1. Everything is positive in quadrant 1. And by we, I mean alpha. Alpha is in quadrant 1. So that must be a positive 4 over 5. Sine of beta. This time you're going to switch and look at this red triangle. That's the beta triangle. So we want sine of that. Sine is opposite over hypotenuse, which is 12 over 13. But it must be negative. And this is super important. I want to stress this. It has to be negative because your beta is in quadrant 3. And the only thing that's positive there is tangent. So because we were finding sine, it's going to be a negative answer. That's really important because it's going to change your entire answer. If one thing is wrong in sine, then as you're simplifying, which is our next step, the whole thing is going to be off. So pay attention to that. Check the quadrants. That's why they told you. If it didn't matter, they wouldn't have told you. Okay, so now we want to simplify this. So we need to multiply. The way that we multiply fractions is straight across the top, straight across the bottom. So I have a 3 times negative 5, that's negative 15. And on the bottom, I have 5 times 13. 5 times 13 is 65. So that's what we get there. Plus, you have 4 times negative 12, that's negative 48, over 5 times 13 is 65. Lucky for us, we can just add these together because they are a common denominator. So negative 15 plus negative 48 is 63, negative 63, over 65. So that's going to be our final answer there. So sine of alpha plus beta is going to be negative 63 over 65. It's kind of interesting. You might say, what does this even mean? Well, we don't know what these angles are, alpha and beta. They're just some angles. Alpha is some angle in quadrant 1. Beta is some angle in quadrant 3. And this is asking me, well, if you were to add those 2 angles together, these 2 sort of unknown angles, and then find sine's value of that new angle, it would end up being negative 63 over 65. So pretty interesting. Let's talk about part B. So part B, so these all look kind of similar. Tangent's probably going to be the most interesting because we know tangent has a unique formula. That's what we've been recently talking about. But let's do cosine while we're at it. So cosine alpha plus beta, you want to refer to your formula. That's going to be cosine alpha cosine beta minus sine alpha sine beta. So that's a formula we talked about at the beginning of this section. And what we need to do is fill in each of these values. So I'm trying to show it so you can see still the triangles and also what I'm writing. So cosine alpha, that's first. They did not tell us that, so cosine alpha is adjacent over hypotenuse, 4 over 5. It's positive because alpha is in quadrant 1. Next is cosine beta. Cosine beta, they actually told us at the beginning, so if you want to refer to that, you can of course still use your triangle because it's going to be accurate. But cosine beta, they told us was negative 5 over 13, so why not use that? All right, next, sine alpha, also something they told us at the beginning. Sine of alpha was 3 over 5. And lastly, sine beta. Let's use our beta triangle. Sine is opposite over hypotenuse, 12 over 13. It's going to be negative, just like it was in part A, because beta is in quadrant 3, and sine would be negative in quadrant 3. Okay, so this looks similar to part A, but I think we'll still get a different answer. We do need to do what we did before, multiply these, add them together, so we'll get negative 20 over 65, and this will end up being minus negative, so that'll become a plus sign. This is 36 over 65, so that becomes a positive 16 over 65. All right, so there we go. In part C, there is an interesting kind of trick to this. So part C is tangent alpha plus beta. I'll give you the trick, but I still want to practice using the formula. The trick is, I mean, we just found sine and cosine, so remember tangent is just sine over cosine. So you could just divide these two, and then that should be the answer. But let's see how we can use the formula. So the formula for tangent alpha plus beta, we just talked about in the beginning of this video, is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So this is going to be tougher for us to do, but we can do it. Let's go. So let's go ahead and look at our triangle. So it's a little bit harder because mine's at the top of my page. Tangent alpha we have to do first. That's what we want first. So tangent alpha, looking at this, tangent is opposite over adjacent. It's going to be 3 over 4. We're in quadrant 1. Everything's positive, so that's a positive 3 over 4. Plus tangent beta. So go ahead, look at your beta triangle. Beta, tangent is opposite over adjacent, 12 over 5. We're in quadrant 3. Tangent is positive there. So it's going to be positive 12 over 5. And lucky for us, that's all we really need because the rest of the formula reuses those. So it's going to be 1 minus 3 over 4 times 12 over 5. Okay, so now it's up to us to simplify this. We've had some practice doing this. We'll have to combine fractions, get common denominators, all that good stuff. So before I do that, I'm going to simplify the denominator. So I'm going to actually multiply these fractions together. If I can't, actually we can reduce them a little bit, so I'll want to do that. Well, will I? No, let's just leave them. So multiply these fractions together. 3 times 12, 36 over 4 times 5 is 20. So that'll be helpful because it looks like I'm going to have the same denominator on the top, so that's great. Okay, so we want to combine these fractions together. They need common denominators in order for us to do that. And it looks like the Common denominator for everything here is going to be a 20. So you need to multiply things appropriately in order to get a common denominator of 20. So for me on the top first fraction is getting a 5 on the top and bottom. The second fraction is getting a 4 on the top and bottom. And then in the denominator, this 1 is going to need to be multiplied by a 20 over 20. So this will become a 15 over 20 plus a 48 over 20, all over a 20 over 20 minus 36 over 20. Okay, now we can combine those together because they have common denominators. We will get 15 plus 48, that is 63 over 20. And then on the bottom, 20 minus 36 is a negative 16 over 20. We're almost done. Our last step really is to KFC. We have a fraction divided by a fraction, so we're going to keep flip change. I'm going to keep the top the same, so this is going to be a 63 over 20. I'm going to flip the bottom, it's going to become a negative 20 over 16, and this changes to multiplication, so that was KFC. We can simplify, so the 20s will cancel. The negative is still there though, so don't lose the negative. And I believe that's all we can do, so we can multiply straight across. There's not much left, so it's going to be a negative 63 on the top and a 16 on the bottom. So that's how you can use your formula to get that answer. Again, you could have sort of faked it because we found sine and cosine earlier, so you could have just done sine divided by cosine, the two answers that we found earlier. But this is a way you can do it without having to find those two things first. Alright, so yes, it's a bit of work, but hopefully this setup looks familiar. Building triangles. This time we had two triangles. It's almost more fun, but you want to pay attention. Make sure you're referring to the correct triangle based on the angle that they give you. Also, please, please, please pay attention to the signs. Where is the angle located? The quadrant will tell you the signs of your answers. So pay attention to that. Alright, that's it for this section. Good luck. If you have any questions, let me know. Otherwise, I will see you in the next section.